So when we're solving by substitution, we want to get a variable by itself. For this first problem, there was no variable completely by itself, but there is one easier to get, which would be this x right here. So I'm going to move the 8y over. So this equation will now be x equals negative 8y minus 38. All right. So far, so good. And then I'm going to take that and I'm going to put it into the other equation in place of my x. All right. So I'm going to say 13 times negative 8y minus 38 plus 7y equals 88. All right. So now I need to solve for y. I'm going to do that first with distribution. So I'm going to say 13 times 8 is 104. Yes. And then 13 and 38 is, all right, plus 7y. Like I said, I won't give you numbers this big. All right, combine these guys. Negative 104 and positive 7. You're going to get what? A negative 97 minus, that's y. Y minus 494 equals 88. Add that to both sides. You get negative 97y. I'm going to assume this guy goes in perfectly. Equals. No. 582. Yep, that'll be 6, I assume. 6, 42, 54, yep. So that's going to equal negative 6. Plug them into either one. I would probably plug them in here, but it doesn't matter where you plug them in. So x is going to equal negative 8 times negative 6 minus 38. That's positive 48 minus 38. X is going to equal 10. Second one's already set up for you. So you have one already by itself. That's the y. So you're going to plug that in there. And so you have x plus 3 times 1/2 x equals 25. Remember when you're multiplying, that's just 3 over 1. So we have x plus 3/2 times x equals 25. Get a common denominator. 2 over 2 plus 3 over 2. That's 5 over 2x equals 25. To get rid of a fraction, you divide or you multiply by the reciprocal. Right, these cancel. Once again, this is over 1 and you can cross cancel. So x equals 10. Once I have x equals 10, I can plug it in right here. Y is 1/2 of that, so y is going to be 5. So the elimination method, it can also be called the addition method because the process by which we eliminate a variable is addition, okay? And so basically what you're going to be doing is you're going to be adding or subtracting the equations together in order to cancel out one of the variables. So in order to do that, the variables have to be opposites of each other. So if you have a 2y, you need a negative 2y for you to add them together and cancel, right? And that's just how addition works. You have to have the opposite when you're talking about the coefficients. And so sometimes they'll be very simple and they'll be handed to you and they'll go ahead and have the opposites. And sometimes they won't be and you'll have to multiply one or both of the equations sometimes to get a common multiple where they can cancel each other out. And then once you have one multiple solved for, or one variable solved for, you're going to plug that back in just like we've been doing with substitution and solve for the other variable. All right. So the first one that they give us is example 1. In this example, you have 4x minus 2y equals 13. You have 8x plus 2y equals 23. My whole goal is to add these two together in hopes that I will eliminate a variable. So before I even start, I'm going to check to see if that's going to work. So I'm going to look at my x's. If I add 4 and 8, I would get 12. Those will not cancel. But if you look at my y's, I have a -2 and a +2. If I add those together, that will cancel. It will turn to 0, okay? And so I can go ahead and add these. I can just say, okay, I'm going to solve by elimination. So I'm going to add these two. I'm going to say 4 plus 8 gives me 12x. -2y and +2y turn to 0, which is fine because 12x plus 0 is just 12x. So I can just cancel those. And then 13 plus 23 is 36. And then I can divide both sides by 12. I get x equals 3. Remember, it's always a point, an xy point for your answer. So I'm not done yet. I have to take that 3 and I have to plug it back into one of the equations. So if I say 8 times 3 plus 2y equals 23, then I would say 24 plus 2y equals 23. Subtract my 24. I get 2y equals -1. And then my final step, divide both sides by 2. My y equals -1/2. And once again, my answer here is going to be my xy, 3, -1/2. And that is elimination. So it's really nice when they're given to you with the variables already opposites of each other. So then you can have ones that are really close. So if I look at this, 3 plus 3 will give me 6, 2 plus 5 will give me 7. But if one of these were a negative, then I could add them, right? And so think about this. Whatever you do to one side of the equation, you can do to the other, and it doesn't change the equation. Meaning I could multiply one of them by -1, every single piece of the equation by -1, and then that would solve my problem. All right. And so I can take this and I can say, well, I am going to multiply this first guy right here by -1. Every single piece of it has to be multiplied by the number that I choose. In this case, -1. So that would make my 3 negative, that would make my 2 negative, and that would make my 8 negative. Now, if I add down, will I eliminate a variable? Well, yes, -3x and +3x. So once I fix that problem, I can add. Now, you could also look at it like you could subtract. I will say if you start adding one time and subtracting the other, you may confuse yourself. So what I do is I just negate everything when I need it negated and I add. So I always solve by addition. I don't ever subtract them, even though technically the process is the same. So I have -3x and +3x. Those will cancel. -2 and +5 will give me a +3. And then negative 8 and positive 14 are going to give me, negative 8 and positive 14 is going to give me a 6, right? And I think they did it opposite in the book, but that's okay. Divide by 3, y equals 2. In the book, they actually negated the second one. That's fine too. They just ended up with a negative 3 and a negative 6. You'll end up with the same y value no matter which one you negate, okay? I just negated the top so that I didn't end up with negatives at the bottom. But they negated the bottom one. It doesn't matter. You still end up with y equals 2. And then once you have y, you're going to go back to either equation. So you're going to say 3x plus 2 times your y value equals 8. Or you could say 3x plus 5 times 2 equals 14. You'll get the same answer. So 3x plus 6 equals 8. Subtract my 6. No, I'm doing it right. It's plus 4. Subtract it. You get 3x equals 4. X equals 4/3. Same thing down here. If I did this one, 3x plus 10 equals 14. 3x equals 4. X equals 4/3. So my answer here is going to be an x value of 4/3, a y value of 2. All right, solve the system by elimination. So the first thing we do is check it. 2 plus 4, that's 6. 3 and negative 9, that's negative 6. We have a problem. Nothing cancels, not even if we negate it, okay? But if I can multiply everything by a negative 1, I can multiply everything by a negative 2 or a negative 3. I can multiply the entire equation by any number that I want to. And so now at this point, I'm going to say, what's the easiest variable to cancel? So you could say, maybe I want to cancel my x's. Well, in order to do that, this guy would have to be what? Negative 4. If he's positive 4, he has to be negative 4, which means I would need to multiply this entire equation by negative 2, right? Or some people would say, well, no, I don't want to mess with negatives. I want to get rid of my y's because I already have a positive and negative. Well, if that's the case, what does this need to be? A positive 9. So I can multiply the entire equation by 3 if I wanted to, right? Yeah, you want to multiply to get it, not add. So you want to multiply the whole equation by some number. So you could do this multiple ways and you will still get the same answer. You choose the easiest method for you, okay? And so if you want to eliminate the x, we would multiply by negative 2. So let's just do that one first and we'll see what it looks like. This means I am multiplying everything in that by negative 2. Okay, so negative 2 times 2x is going to give me a negative 4x. Negative 2 times positive 3y is going to give me a negative 6y. And negative 2 times positive 5 is going to give me a negative 10. Now, if I add, will I cancel something out? Yes, I have a positive 4 and a negative 4. Those will cancel. And so now I'm ready to just do the addition like I've done before. Positive 4x and negative 4x cancel. Then I have a negative 9y and a negative 6y. That gives me a negative 15y, right? And then I have a negative 10 and a negative 10. That gives me a negative 20, all right? Now I will say, So we're going to divide both sides by a negative 15. Y is going to equal this guy. Negative over negative is a positive, and I can reduce it. What comes out of both of those? I can divide them both by 5, right? So 20 divided by 5 and 15 divided by 5. So my Y value is 4/3, all right? And then I can plug that back into either equation. It doesn't matter which one. So if I say 2x plus 3 times my Y, 4/3, equals 5. Remember, this is 3 over 1, so my 3's actually cancel here. So I have 2x plus 4 equals 5. Subtract my 4 over. 2x equals 1, and divide by 2. X equals 1/2. So my answer here is going to be 1/2 for the x, 4/3 for the y. All right, so in this case, this is different than the other one. In the other one, I actually had multiples. So I had 2 and 4. 4 is a multiple of 2, right? And I had 3 and 9. 9 is a multiple of 3, right? And so I could just take one of the equations and multiply to get it to the other number that I needed. In this case, I don't. I have 2 and 3, and they're not multiples of each other. So now I'm going to look for the least common multiple that they do have, all right? And so the least common multiple, and this is true for x and y in this particular case, but for x's, my least common multiple between this is going to be 6, and my least common multiple between this is going to be 6. So really, either one is going to have to be multiplied by the same size of number, but one of them is already a positive and negative for me, right? And so this guy is already positive and negative. So because of that, I would actually decide to eliminate my y variable first, because it's already set up to be positive, negative. So I need both of those to be 6, and I need to be 6 with one of them positive and one of them negative, okay? And so to get this top equation, I need the 3y to be a 6. What do I need to multiply it by? 2. And for this bottom equation, I need the negative 2y to be a negative 6. What do I multiply that by? 3. And that's what I'm going to do. And so I'm going to multiply every piece of it by 2. So 2 times 2x, 2 times 3y, and 2 times 6. And I'm going to do the same thing with the bottom equation. 3 times 3x, 3 times 2y, and 3 times 8. All right? And now that I've done that, now I'm ready to just add, because now I have a variable that will eliminate. All right, so 4 and 19, that give us 13x equals, this is going to cancel, 12 and 24 is 36. Divide by 13. 13 is a prime number that does not go into 36. So that is your x value, which means we get to plug that in, and it is not going to be pretty and eliminate like the last guy did. Remember, his denominator canceled. This one's not going to, so we are going to have to add and subtract fractions. So it really, at this point, doesn't matter which one you plug it into. So if I go back, I can plug it into one or the other. Here's the thing, though. If I want to, instead of dealing with fractions, I could go back and eliminate y and solve. Go back and eliminate x and solve for y, right? Like, here's your options. You can plug 36/13 into either equation, and you can multiply and then subtract it over, get a common denominator, and divide. That sounds beautiful, right? Or I could go back to my original equation, and because x is just as easy to cancel out, I could do that, right? And so I can go back to my original equation here, and I can say, well, now that I solve for x, I'm going to solve for y by elimination. So I'm going to eliminate my x variable now. And so to do that, I'm going to say, well, I need both of these to be a 6 and a negative 6, right? And so I'm going to multiply the top one by positive 3. And I'm going to multiply the bottom one by negative 2. And this time I'm going to eliminate my x. Now, again, you can plug that 3613 back if you want to, or you can go eliminate your other variable. It will give you the same answer, okay? So if I do this, my equation is going to look like this. I'm going to have 6x plus 9y equals 18. And I'm going to have negative 6x plus 4y equals negative 16. Now this time my x's will cancel. I will get 13y equals 2. And then when I divide by 13, I will see that y equals 2 over 13. That's my y value. Again, you could have gone back and you could have said, well, 2 times 36 over 13 plus 3y equals 6. And you could have solved that if you wanted to, right? But this way seems harder than just eliminating your other variable to me, right? And so you can plug it in. If it's just a whole number, I'm just going to go plug it in and solve real quick. I'm not going to do the whole elimination process again. But if I get some gross fraction that I can see the denominator's not going to cancel out when I plug it back in, I'm probably just going to go eliminate my other variable. Okay? And so either way you do it, you're going to get this as your x value and this as your y value. To eliminate y, I ended up solving for x. When I eliminated x, I solved for y. Okay? And had this been a pretty, beautiful little integer, I probably would have just plugged it in and solved. But because it wasn't, I chose to go back and solve for the other variable.